Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface and look at how to work with anonymous classes when we are using JNI. Basically, how to add native methods to anonymous classes, and then how to implement them in C++, and then how to call those native methods from Java. So far we've looked at the working with inner classes, a regular inner class, a static inner class, and a method local inner class. And when we looked at the method local inner classes, we said that these method local inner classes are very similar to anonymous classes. And then but the difference was that for the method local inner class, the name, so basically for any nested inner class, regardless of what type of inner class it is, Java C, the compiler, creates a separate class file. And for a method local inner class, the name of the class file was outer class $1, and then the name of the method local class. And we said that $1, it's similar to anonymous classes. Anonymous classes get compiled to a $1, $2, etc. But for a method local inner class, it's always compiled to $1 and the name of the class, because method local inner classes are not entirely anonymous. They actually have a name. So the compiler adds this $1 to signify that, hey, these are some sort of local creation of the classes, but then these classes have a name, so they're not entirely similar to anonymous classes. But now let's look at what happens if we actually create a fully anonymous class and add a native method to it. So the scope of definition for anonymous class is inside the scope of a normal variable. So whatever scope that we define them in, instantiate them, then it's just the scope of the class. We define them when instantiating a class or even an interface. Typically the use case of anonymous classes is for interfaces, but we can actually instantiate a concrete class and then but instantiate it in a way that is similar to instantiating an anonymous class, and the compiler will see that instantiation as a anonymous class. So the class path description of anonymous classes is outer class $x, and the x is a numeric character 1, 2, 3. If we instantiate twice, we get $1, $2, and when we use Java Edge in the header file, basically dollar is replaced by _00024. all right, and then x is basically 1, 2, 3, etc. how many inner classes, anonymous classes we instantiate. And so $x is replaced by _00024. This is the dollars part, and then the x is the number 1, 2, 3, etc. So outer class $1, this is the first anonymous class that we instantiate inside the outer class. And Java Edge, in the function declaration, $1 is replaced by _000241 when generating header files. If for the second anonymous class, this is outer class $2, and then $2 becomes _000242, right? So the compiler generates a separate class file for each anonymous class, and we can actually see the full class declaration of that anonymous class if we do a sysout on that anonymous class dot class. So if we look at the meta information of that particular class, this class file is a meta information in the meta space of the JVM that describes the personality or this entity. Let's say this is a person class, right? Anonymous classes can also have native methods. I've never seen anyone actually using native methods inside a anonymous class, but they can have, and that's the whole purpose of this tutorial. And this is very similar in behavior to method local inner classes. And just like the method local inner classes, we can easily run java h-jni on the class path description of the anonymous class. So if we run java h-jni on the outer class, it won't be able to generate a header file for the native methods inside the anonymous class. And this is similar to when we dealt with method local inner classes. So we have to manually run java h-jni on the class path description of the anonymous class itself, not on the outer class. So this generates a header file for the inner class or the anonymous class. Note that if we run the java h-jni tool on the outer class, we do not get a header file for the anonymous class. All right. So what happens when we manually run java h-jni on an anonymous class? So we know that the outer class is described by package.outer class, and this is the package hierarchy, and then the outer class. And then the anonymous class gets the description of $x. X is a numeric character, right? This is a full class path description of this anonymous class. And then when we run java h, basically java h strips away the first part of this description until the $sign, right? So first of all, we cannot have entirely this as a even if we replace dot with underscore, which basically java h typically does, we cannot have a $sign in the header file name, so this $sign should be replaced. So what java h does, unlike the inner classes or static inner classes for anonymous classes or method local inner classes, java h strips away all the description before the $sign, right? And then it also removes the $sign, and the header file will have the name x.h. This is what basically the java h sees. But then x is a numeric character, and header files cannot start with a numeric character. The name of a header file cannot start with, let's say, 1 or 2, right? So java h removes x, also removes this numeric character x, which can be 1, 2, etc. from the name of the header file. So eventually the header file that the java h creates for a anonymous class becomes nothing. There is no name because every stuff before the $sign was removed. The $sign is removed, and x was also removed. So instead of having 1.h, it becomes nothing. The name is empty .h. And if you run on a macOS, this is a hidden file, so you don't immediately see this generated header file because the name is empty. Anything that starts with a dot is like a hidden file in macOS, and I believe in Linux too. In Windows, I think it's not considered a header file, so you can see it, but in macOS you don't immediately see it. You have to try to look at it as a hidden file. And then what we need to do, we need to simply rename this file, this header file that has an empty name, to something more meaningful, right? And again, note that in general, the name of the header file that the java h creates doesn't really matter. We can rename it to whatever we want. The thing that matters when we are dealing with JNI is the name of the C or C++ function, right? And that was java underscore package name underscore class name underscore method name. If it's overloaded, then underscore underscore the method parameter signatures. That's the only thing that matters. At runtime, when Java loads the JVM loads the dynamic library, it looks at for this symbolic binding, right, for the function. So it doesn't care what's the name of the header file because it doesn't see any header file. In C++, the GCC, the C+ compiler, combines the header files with CPP files and creates a dynamic library. And inside the dynamic library, the only thing that is available is this basically function symbols. And the JVM just looks into that dynamic library, loads it, and then resolves these symbolic references to the Java methods. All right. So eventually the name of the header files doesn't matter. So we can rename it to whatever I want. Similar thing happened for the method local inner class. So when we ran manually java h-jni on a method local inner class, I call it MLI class, method local inner class. The description of the method local inner class is package.outer class $1. It's always $1. Unlike anonymous classes, which is $x, and x can be 1, 2, 3, etc. For method local inner classes, it's always $1 because method local inner classes, they do have a name, so the name of the class is attached after $1. And this is the generated class file that the Java C creates. And again, Java H strips away everything before the $sign, and then the $sign is also removed, and then the name of the header file ends up being one ml class method local inner class name .h. And then because the header files cannot start with a numeric character, so Java H also removes this one. So we end up with the name of the method local inner class .h. And this is what we exactly saw in the previous lectures. So I had a student class that was a method local inner class, and when I ran java h-JNI manually on the class description of that method local inner class, I get a student.h header file, right? So that's so the reason that Java H removes this one also is because the header files cannot start with a numeric character. So we also need to drop this one. And method local inner classes, they do have a name, so eventually the name of the header file becomes the name of the inner class .h. Now, a very interesting thing that you might be asking right now is, why is that $sign is replaced by 00024, 3 zeros and a 24? Now, obviously there's an underscore, but that's a general rule. That's just a separator that Java recognizes when binding to a basically Java method. So this underscore is a standard, but then the $sign needs to be replaced by this 00024. So the question is, why is $sign is replaced by 0024? And the answer is that Java recognizes UTF-16 encoding for strings, and a source file is also a string. So basically when Java JVM loads the dynamic library, it needs to symbolically resolve these strings, right? Java underscore package name underscore class name underscore method name. And because for strings Java uses a UTF-16 encoding, we can just go and Google what is the UTF hexadecimal UTF-16 representation of a $sign, and here's the result of Googling it. You see, UTF-8, it's hexadecimal 24. UTF-16, basically the hexadecimal representation is 24, and 24 is 1 byte, right? So in UTF-8 hex representation, it's 1 byte, so it's 0x, which means it's a hex representation, it's a hex number 24. And then obviously in the binding we just simply remove this x and it becomes 024. So if JVM was using UTF-8 then or ASCII, then it would have replaced $sign with 024, which is 1 byte, right? It's a hex. But because it uses UTF-16, UTF-16 is 2 byte in general, right? And again, the $sign is just 24 hex. So we have 2 extra zeros for the second byte, which is just 0 because this is still 24 hex. And then we have this, and we remove this x, and the UTF-16 representation becomes 0, which denotes that this is a 0x or hex representation. And then the actual hex value is 24. For 2 bytes, the first byte is 0, the second byte is 24. If we use UTF-32, it's 4 bytes, right? And the first byte is 24, the second byte becomes 0, the third byte is 0, the fourth byte is 0. So we end up with 2, 4, 6 zeros, and then we also add this extra 0, so it's basically 7 zeros. Some number of zeros, which is 7, so 6 zeros for 3 bytes, and then 0x, which is hex, right? But JVM uses UTF-16, so we end up with this hex representation, and then 0, 0, 0, 3 zeros, and a 24. This is a 2 byte representation. All right, that's just if you were considering or thinking why this $sign is replaced by this mysterious number. That's just because it's the hex representation of the $sign in the UTF-16, which is 2 bytes. All right, so let's head to Eclipse. So I have created a new package in my native Java project, and in the package I have created this person as usual, and this person has a name, a string, and an int age, and in the constructor I'm initializing them, and I just added this method print void print info, public void print info, and it does some stuff, right? All right, so in the test anonymous class, this is a test, and in the test one, I'm just instantiating this person class as usual. I give it a name Bob, age 21, and call this print info method. So if I run this, it just basically gives me the name equals Bob, which is what happens in this print info method, right? It just does a sysout on the name equals whatever the name is. Now, if I look at this basically bob.get class, the class file description of this object, it should be a regular class. So it's the package name test26.person, which is a class, right? It's a regular class, nothing unusual, so regular class. However, I can also basically create an anonymous instance of this class when I instantiate it. So creating anonymous classes is not just for basically implementing interfaces. I can also create an anonymous class just for a concrete class. So if I say person Bob equals new person, all right, again Bob 21, this is a regular, but I open and close these curly braces, and then this gives this object Bob an anonymous entity. So let's see if I do a sysout on bob.getClass. Let's see what happens. Now it becomes an anonymous class. It's not a regular class anymore. It's not a regular instantiating of this person object, because I open and close a curly braces. It means I could actually change the internals of this class, right? And that's what I'm actually going to do in a moment. But as you can see now, the identity of this class is basically package.outerClass $1, right? So if I create a new one, let's say Bob2, and then look at its metadata, Bob2, I expect to see $2, which means this is the second instantiating. Yes, this is the second anonymous instantiation of this person class inside this test anonymous class basically file. All right, so I'm creating a anonymous class from a concrete class. So usually we do this for just interfaces, but it's also possible to do it for basically concrete classes. So what can I do now? I can actually override this print info method. So if I go to source, override implement methods, I can override this print info, which is a public method, and it's not final, so I'm allowed to override it. Okay, and then what happens here is that by default it just calls the info method in the superclass. But what I'm going to do, if you recall in our early lectures, we said that we can override a regular non-native method with a native method. So I'm going to say that public native void. All right, and native methods should not have any body or implementation. So this is still a valid override, but we are overriding this non-native method with a native method. All right, and this is still valid. So if I run test2, it should still work fine. Yes, but obviously if I call this bob dot print info, it's going to call this overridden method, its native method, and then actually it's a void method. So bob.printinfo, we don't need to sysout on this, and it throws the unsatisfied link error. It says test26.testAnonymousClass $1 print info. It couldn't find it. So if I comment this out, what happens then? It probably goes to and calls this method in the superclass, right? So let's see. Yes. So this is some interesting way of overriding stuff, overriding methods, and now I'm trying to override it with a native method, right? So okay, so one thing is that, as I mentioned, if I select this class that has a native method and run my Java Edge tool, This one, which takes the job, it doesn't create any header file. We've seen this before for the method local inner classes, and this is the similar things, because the Java H, when it looks at this Java class file, it doesn't see this person class, because it's really not in the scope of the entire class. It's in the scope of this method. So outside this method, this Bob class, this anonymous class doesn't exist. All right. So Java H doesn't see it. So what I'm going to do, I'm going to, when we do a CSAT on the get class, we take this, copy it, and then I can go select the Java H and then select this, duplicate it, which I've already done it, and everything is the same except for the fact that instead of saying Java type name, I manually ask Java H to run on this particular class file, which is test26.testAnonymous class $1, which means I'm manually asking Java H to run on this anonymous inner class. All right, anonymous class. So if I run this, okay, empty selection, project name. Let's see what happened. We are in the workspace project bean, and then -d. We want to put it in the native C header, and then Java H. So this should work fine. Yes. So it worked fine, and then the header file is now created. So if I go to the C++ perspective, so test26 in the Java project, and let's look at the header files, header folder. No, it's not here. This student file was from the method local inner class example, but there is nothing. We don't see any header file in this header folder for this person class. Why? Because as I mentioned, what the Java H creates is basically the name that Java H generates is .h, and this is by default a hidden file in the macOS. So if I go to navigator and look at the project, actually there is a .h file, and it's correctly saying that it's a bundle to Java underscore test26 test anonymous class underscore the $, which is 00024, and 1, which means this is $1. So basically this means $_1, and this is my anonymous class, and the method is print info. So this is correct, but this is a hidden, it's more or less a hidden file. So what I'm going to do, I'm just going to rename it to let's call it anonymous. Again, the name of the header file doesn't matter. The only thing matters is the name of this function, and it should and again the $, is replaced by a 2-byte UTF-16 0024, and this extra 0 is from saying that it's a 0x or a hex representation, and this 1 comes from the fact that this is for the method for the anonymous class. So going back to the project explorer, now I have this header file. What I can do, I can go to the source and create a source file. Let's call it anonymous.cpp, and as always, the very first thing that we do, we include that header file header anonymous, and then we copy and paste the description of the function. And note that this class file doesn't have a name, because everything all the way to 1 was stripped away, and because this class doesn't have a name, it doesn't have any class name here. So JNI environment pointer, JVM, JObject, it's the calling object, which is this this anonymous class actually, which doesn't have a name. So let's call it anonymous obj. All right, what I want to do, I just want to, let's just print a simple message. So include IO stream, and then let's say std cout, hi, I'm a anonymous class. and std end line. All right, and let's just compile this project. Okay, compile is done, the dynamic library is generated, so I'm going to copy it and paste it in my JNI folder, and I'm going to replace the old one. And now if I go back to my test anonymous class, and I've already loaded dynamic library in the static initializer, and I should be able to run this print info with no problem. Yes, and it says, hi, I'm an anonymous class, which is coming from the C++ implementation. So if I just hide this or comment this out, it's going to call the superclass method, which is inside the person. And if I uncomment it, it's going to call the C++ implementation of this method, which is relatively cool. I've never seen anyone using this, but I can imagine very interesting use cases for this kind of native methods inside the basically anonymous inner class that is from a concrete class. Now what happens if I instantiate this one more time? So bob2, and I'm calling the print info bob2. So this second one, its class file is $2, but in the anonymous header we have $1. So what I think is going to happen is that this probably is going to throw an unsatisfied link error. And let's try it. Yes. So it says that I cannot find test26.testAnonymousClass$2.printinfo. And again, that's the main problem, because this $1 gets encoded in the method in the function name in C++. So we cannot really use the implementation of the one anonymous class for another one. That's not going to happen. But obviously if I go here in this header file and add another one with $2, right, and then here I just add an implementation for that one. Hi, I'm the second anonymous class, and then I just quickly compile. Okay, and then copy and paste the dynamic library back to my Java project and run this. This should work fine for both of them. Hi, I'm an anonymous class in C++. It comes from this one. And hi, I'm the second anonymous class, which comes from this one. And again, the reason is that when we create an anonymous class, this $1 gets appended, and then it's also included in the function name in C++. Therefore, for different anonymous classes, the function calls are different. So for this class, this is the first one. Java, when JVM loads the dynamic library, it knows that it has to call the function that has the 1 or has the description of $1 for the second one. So if I comment actually the first one, then this bob2 becomes the first instantiation of this basically anonymous class, and then it's going to call the first one, this $1 from C++. So if I run this, yes, hi, I'm an anonymous class, which is for the first instantiation. Now obviously we can have as many as we want, 2, 3, 4, 5, but note that this is the main limitation of this approach, because this native override is really bound to the signature of the anonymous class. So the more, if we cannot instantiate other inner classes, the second one or the third one, we have to have separate C++ implementation that correctly matches the number description of the anonymous class. That's the problem. Now note that this was not the problem for the method local inner class, because in the method local inner class we actually have the signature is always $1 and then the name of the class, so it never changes to $2 or etc. So for method local inner class, we can have a native method inside it, and then we can instantiate it as many times as we want within the scope of that method, and all of them will call the same native function in C++. But for anonymous classes, it's not the case, because this $1 gets incremented to $2, $3, etc. And because this $1 or $2, it's baked inside the C++ function name, different anonymous classes, even if they're within the same scope, they don't call the same C++ functions. That's the main thing that I want you to understand. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.